Today we have new topic, mechanical energy. After this lesson, you will determine mechanical energy analytically, will know types of energy, explain relationship and difference between kinetic and potential energy, and use it for problem solving. So let's answer to this question. What physical quantity is called energy? Energy is an ability to do work. We do work by using energy, so we can say that work and energy should have the same units. Both work and energy are measured in joules. In our previous lesson, we learned about work, so let's remember. In this picture, you can see two bodies moving in the same direction. Distance between two bodies is 4 meters. We can find work using formula. Work is equal to force times distance. Force is equal to 50 newtons. Distance is equal to 4 meters. So work is equal to 50 newtons times 4 meters is equal to 20 joule. On the next table are given some typical work values in daily activities. When we're opening a door, we spend 5 joules. When we're throwing a brick, we spend 75 joules. When we're climbing the stairs, we spend 1,500 joules. Energy of 1 joule. What is it? Energy of 1 joule is equal to the energy used in lifting an apple from a table to your mouth. Dear students, there are different types of energy. Let's watch the video.
Exactly what energy is. Does it come from fire, electricity, the energy drinks we drink? Actually, it comes from all of those things. Energy is what keeps the world going. Let me break it down for you. The first thing you need to know is the law of conservation of energy. It sounds hard, but it's actually simple. It means that energy cannot be created or destroyed, but only converted between different forms. Yes, you heard it right. Energy lasts forever. I'm serious. It changes, but it never disappears entirely. So let's look at some different forms of energy. There's electrical energy, which is the current that goes from your plug point all the way to your lamp and lights it up. Then there's mechanical energy, or what scientists call kinetic energy. That's the energy of movement, like when you walk across the road, or when a car's wheels turn. Oops! Well, that was kinetic energy being transferred from the moving car to the pedestrian. But that's a whole other lesson. Let's look at some more forms of energy. Next, we have thermal energy. The biggest source is obviously the sun's rays, but it's also the heat that cooks your food. There's also chemical energy, which comes in the form of gasoline, oil, and even the food we eat. Finally, there's nuclear energy, which comes from the splitting of atoms, like they do in nuclear power plants. Pretty cool, right? So now you know some of the basics about energy. We know it comes in many forms: electrical, kinetic, thermal, chemical, and nuclear. But don't forget the most important part. Energy cannot be created or destroyed. It can only be converted between different forms. And that's the basics of energy. It's so simple.
Dear students, thank you for watching this video. And what we can say after this watching video: energy cannot be created or destroyed, but only be converted between different forms. It changes but never disappeared. Different forms of energy: electrical energy, mechanical energy or kinetic energy, thermal energy, chemical energy, nuclear energy, and we've given examples from our daily life. Where does the energy come from? The higher the gamma is lifted, the more energy it gains, and the farther the nail enters into the wood. Examine. The work done on the object is stored as a type of energy. This energy is called potential energy. There are two types of potential energy. Let's think why it is so hard to climb up the stairs. You have a few minutes. Because climbing a flight of stairs uses more muscles than walking. We spend more energy. What is potential energy? It's a type of energy due to the position of an object. There are two types, as I said: gravitational potential energy and the elastic potential energy. Gravitational potential energy is an energy that is stored in an object due to the work done during lifting. The formula of potential energy is equal to mass times acceleration of gravity times height. The unit of energy is joules, the unit of mass is kilogram, the unit of acceleration of gravity is meter divided second square. The unit of height is meter. Elastic potential energy, springs. Potential energy is equal to spring constant times spring displacement squared divided 2. What is elastic potential energy? Work done by the external force in pulling the spring is stored as the elastic potential energy of springs. Examples: a man lifts up a 1.5 kilogram box on the table, which is 120 centimeters height. How much potential energy does the box gain? Acceleration of gravity is 10 newtons divided kilogram. So let's solve these problems. Dear students, we will solve problems for potential energy, for finding potential energy. First problem: what is given for us? Given mass is equal to 4.5 kilogram. Height is equal to 120 centimeters is equal to 1.2 meters. Acceleration of gravity G is equal to its constant 10 meters divided second square. We must find potential energy. Potential energy solution. Potential energy is equal to mass times acceleration of gravity times height. Potential energy is equal to 4.5 kilogram times 10 meter second square times 1.2 meter is equal to, it will be 54 joules. Answer: potential energy is equal to 54 joules. Solve second problem. A spring has a spring constant of 20 newtons divided meter. Calculate the elastic potential energy stored in the spring if it has been extended by 25 centimeters. Let's solve second problem. Given spring constant is equal to 20 Newton divided meter. Spring displacement is equal to 25 centimeter is equal to 0.25 meter. We must find potential energy. Solution. Potential energy is equal to spring constant times spring displacement squared divided 2. Potential energy is equal to 20 Newton divided meter times 0.25 meter times 0.25 meter divided 2. 20 divided 2 is equal to 10. Our answer is 0.625 joules. Answer. Potential energy is equal to 0.625 joules. Dear students, mechanical energy is divided to two energies, potential energy and kinetic energy. We will now learn about potential energy. So let's answer next question. What is kinetic energy? The energy of an object due to its motion is called kinetic energy. Its formula is kinetic energy is equal to mass times velocity squared divided 2. Kinetic energy is measured in joules. Mass is measured in kilogram. Velocity is measured meter divided second. So let's solve next problems. Students, next problem. Given for us. First problem. Given for us, mass is equal to 1.6 kilogram. Speed is equal to 5 meter divided second. We must find kinetic energy. Solution. Kinetic energy is equal to mass times speed squared divided 2. Kinetic energy is equal to 1.6 kilogram times speed squared 5 meter divided second point times 5 meter divided second divided 2. As you know, 1.6 divided 2 is equal to 0.8 kilogram. It will be 25 times 5 is equal to 25. 25 times 0.8, it will be 20 joules. Answer of our problem is kinetic energy is equal to 20 joules. Next problem. Given for us, mass is equal to 95 kilogram. Speed is equal to 10 meter divided second. We must find kinetic energy. Solution. Kinetic energy is equal to mass times second square. Mass times speed squared divided 2. It will be mass 95 kilogram times 10 meter second times 10 meter second divided second divided 2 is equal to, it will be 4,000 750 joules, or it will be 4.75 kilojoule. Answer: kinetic energy is equal to 4.75 kilojoule. And the first problem dear students, given for us mass of cyclist 43 kilogram, mass of bicycle 7 kilogram, speed is equal to 4 meter second divided second. You must find kinetic energy. Solution. Students, third problem, it will be your home task. You must find kinetic energy. So students, your homework, textbook paragraph 31, and answer the question after paragraph.